Right now, beneath the surface of the Pacific Ocean, a mass of water the size of a continent is quietly moving east. It is running 7.5 degrees hotter than the water around it. Oceanographers call this deep pulse of thermal energy a Kelvin wave. It is the opening act of an impending Super El Niño, and it is arriving on a planet that is already running hotter than at any point in recorded history. To understand how this happens, we have to look at the Earth's normal climate baseline. For centuries, sailors crossed the open oceans by relying on the trade winds, a permanent band of air that blows consistently from east to west across the equator. This diagram shows how those winds physically drag the warm surface layer of the ocean westward. Over time, this constant atmospheric pressure actually raises the sea level by about 0.5 meters near Asia, piling up a vast, deep reservoir of heat. This means the Earth's standard climate operates like a tightly wound spring. There are billions of tons of warm water held on one side of the planet by nothing more than consistent wind. But that spring snapped this past April. In a single week, 3 powerful tropical cyclones spun up almost simultaneously, all straddling the equator. Because storms north of the equator spin counterclockwise and storms south of it spin clockwise, these 3 cyclones effectively locked together. Their combined rotation pushed directly against the trade winds, reversing the normal east-to-west flow for nearly a week. Without that constant wind pressure holding it in place, gravity took over. The western water mountain collapsed, sending an immense deep underwater avalanche of trapped heat barreling eastward toward the Americas. This single week of weakened wind was all it took to release the Pacific's stored energy, sending millions of square miles of heat barreling toward the Americas. Normally, those east-to-west winds drive a constant vertical cycle off the coast of South America. By pushing the top layer away from the shore, they pull cold, nutrient-rich water up from the deep ocean to replace it. This vertical movement is called upwelling. It acts as an oceanic fertilizer, feeding the phytoplankton at the base of the food chain and supporting one of the most productive marine ecosystems on Earth. This cross-section shows what happens when the El Niño wave arrives. A thick, hot lid of water slams into the coast and violently shoves the boundary layer between warm and cold water, the thermocline, hundreds of meters deep. The cold ocean currents hit this newly lowered warm boundary and bounce back. Because the cold water can no longer punch through to the surface, the upwelling completely stops. Without those nutrients, the phytoplankton vanish. Local fish populations plummet, starving out marine wildlife and rapidly crippling the South American fishing economies. The devastation doesn't stay in the ocean. As surface temperatures in the eastern Pacific spike nearly 3 degrees Celsius above normal, that massive reservoir vents its heat directly into the sky above it. Looking at this global map, you can see how this rising column of thermal energy intersects with the subtropical jet stream. The extreme heat physically bends these high-altitude wind currents, entirely repositioning where storms travel around world. As this distorted jet stream sweeps over the Atlantic, it acts like an atmospheric buzzsaw. This creates wind shear, fast-moving air that tears apart forming thunderstorms before they can organize into hurricanes, leading to a much lower overall storm count in the deep Atlantic. But a lower count masks a severe hidden risk. While the deep ocean is sheared apart, unprotected waters much closer to home, like the Gulf of Mexico, are overheated, creating a perfect breeding ground for sudden Category 5 storms right near the U.S. coast. Meanwhile, that same energized jet stream acts as a fire hose pointed straight at the West Coast. California faces a highly elevated risk of frequent atmospheric rivers, dumping sheer volumes of water that escalate into severe flooding and mudslides. On the opposite side of the Pacific, the effect is inverted. Because the moisture has migrated toward the Americas, countries like Australia are starved of rainfall, plunging them into extreme drought and escalating the risk of catastrophic wildfires. An El Niño is ultimately a massive thermodynamic transfer. The system uses the atmosphere as a conveyor belt to export the Pacific's excess heat to every corner of the globe. We know the exact stakes of these shifts because we have recorded them before. During the 1998 El Niño, rewired wind patterns spawned the deadliest winter tornado outbreak in Florida's history. That same year, the altered currents dumped 100 times the normal rainfall over East Africa. The floods triggered immense outbreaks of malaria, and the largest wave of Rift Valley fever ever recorded. Further back, the stakes were even higher. The 1876 El Niño disrupted global wind patterns so severely that monsoons across Asia and Africa simply failed to appear, causing a sweeping famine that killed tens of millions of people. Now, this incoming Super El Niño is swinging into a completely different environment. It is releasing its stored thermal energy onto a planet that is already running hotter than at any point in recorded history. With 2027 poised to break all temperature records, failing crop yields will directly threaten the food supply for over 1.3 billion people. And this is happening precisely as global fertilizer supply chains are already tangled and disrupted. But humanity is no longer caught off guard. Following the shock of past events, scientists spent decades building vast arrays of deep ocean buoys to monitor this exact threat. That continuous data collection gives us an unprecedented view. We can map this thermodynamic transfer in real time and project its impacts months before it reaches its peak. The heat is inevitable, but because we can clearly see it coming, avoiding a global humanitarian catastrophe is no longer a matter of luck. It is a matter of choice and preparation.